change in time. I want to calculate the average speed of this particular object after 2 seconds. So, how do I do that? In this case, how do I do that? How do I find the distance traveled? Okay, I plug the 2 in. Plug 2 into this formula here. I have 16 times 2 squared. And remember, it's a change in distance. What was the initial distance? After 0 seconds, how far has this thing traveled? It's traveled 0. So I'm just going to go ahead and stick that in here just to get the formula I need. Okay? And now I'm in change in time. Well, the change in time is I started at 2 seconds and subtract after 0 seconds. Okay. So this will calculate my average speed for me. If I do that calculation, what do I get? 64 over 2, which we can abbreviate to 32. And I should put distance traveled in feet. So this would, the units on this thing would be what? In feet per second. All right. So when I drop something, over the first 2 seconds it falls, it's traveling on the average 32 feet per second. All right. What's the average speed between the first and the second second? How do I calculate that? Okay, so again, we're going to use this same change in distance over change in time expression. And what we're going to do is we're going to say, okay, I'll take the 2 second part first, so 2 seconds squared, minus how far it traveled after 1 second. And I'll divide that by the change in my time, 2 seconds to 1 second. And if I do that calculation, what do I get? Minus 16 over 2 minus 1, which gives us 38 over 1, and again, in feet per second. So, what can you conclude? What can you conclude based on the work that we're looking at here? What kind of conclusions might you draw? The average speed over the first 2 seconds was 32 feet per second. The average speed between the first and the second second, 48 feet per second. Seems to me like this thing is speeding up as we're letting it go. Okay? In this case, we see that the difference of that second has increased our average speed by quite a bit. All right.
It's 32 feet per second after 2 seconds.
That's the average speed.
Okay.
That's the average speed. So what you're looking at is you're looking at all of the seconds that it was dropping. It's not what you can. Another thing that you can take from this is that this dropped object is not falling at the same speed the whole time. Its speed is changing as it's falling. And what you should also be looking at here is that as we look at smaller and smaller intervals, as we get further and further down, that speed is getting faster and faster. Okay. All right? So let's take a look at something slightly different. Okay. I would really like to know how fast this thing is falling at 1 second. At that very instant that we have dropped it, and it's 1 second, how fast is it falling right then? And then I'd like to do the same thing for right at 2 seconds. How fast is it falling at exactly 2 seconds? How can I do that? Well, what I'm going to do right now is I'm going to just say, you know, let's make the distances or the changes in my time very, very, very